Okay, the instructions in this problem are to find the dimensions of the right circular cylinder described. Okay. For a cylinder, or I might use your imagination, I don't draw very well. But we got a height associated with it. And then we got the base here, which is a circle. Um, and the circle, of course, has a radius involved with it. So we have radius coming like that. Now, our volume for this type of shape is where you take the area of the base times the height. Now, since the base is a circle, it'll be pi r squared. So the area of the base will be pi r squared, and of course the height is h. Now let's take a look at this a little bit closer. We got the height, and we got the radius. And they tell us the height is 1 less than 1/2 the radius. So the height is being put in reference to the radius. You have to look and see which one it's being put in reference to. This one will be the r, and now we have to think about what this means. And I'm not very good. I have to really think of a number example, wrap my mind around these. I'm not very good at just writing it out. 1/2 the radius would make me think 1/2 r. That seems pretty obvious. Then it says the height is 1 less. So I'm either going to put a -1 or a +1. Let's think about that. Let me put a -1 since I can easily change that. And let's say the radius is 20. It's not, but let's say it is. Okay, so the height is 1 less than 1/2 the radius. So 1/2 the radius would be 10, half of 20. And the height is 1 less than that. So that would say my height is 1 less than that, which is 9. Let's see if that makes sense if I plug that in here. If I put 20 here, that's 20, of course. 1/2 times 20 is 10. 10 minus 1 is 9. Okay, that seems to fit. Now I just do those just so I can wrap my mind around the setup. So volume is 72 pi. So I'll go ahead and put 72 pi there. And we got pi r squared times h, and h is 1/2 r minus 1. Now notice there's a pi on both sides. I could divide both sides by pi and get 72 equals r squared times 1/2 r minus 1. Multiply the r squared through, and I get 1/2 r to the third, and r squared times -1 is -r squared. Now I'm going to take 72 over the right side, so I'm going to have 1/2 r to the third minus r squared minus 72. I'm not even sure how you'd handle it if you left the fraction there. So I'm going to multiply everything by 2. So 2 times 0 is 0. 2 times 1/2 r to the third is r to the third. 2 times -r squared is -2r squared. And 2 times -72 is -140. Let me think. Yeah, -144. This is what we're trying to solve. So this will be my P, and this will be my Q. We need to list all the possible rational zeros. All the numbers multiplied together give me 144. Let me write in this form first. 1 times 144, 2 times 72, 3 times something, 4, 12, 24. Okay. 4 times 3, 12, 24. 2, okay. 5, no. 6, maybe. 12, 24, 24. Okay. 7, no. 8, yeah. 8 times 1. Let me think. 64, 18. 9, yeah. 1, six, okay. And 10, no. 11, no. 12, I think. Yeah, oh yeah, 12 times 12. Okay. So, for my P, do plus or minus, and I'm just going to list all these down with a plus minus before each one. Plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8. You can use tricks like Descartes, or not a trick, but you can use techniques like Descartes' rule to kind of reduce down the possibilities and so forth. I'll just go about it through brute force because I'm hoping I can kind of see it. Let's see, plus or minus 72 and plus or minus 144. Now Q, the number that's in front here is a 1. The only thing that gives that to me is a 1 times 1. Now all of our possible rational answers would be P over Q. So I take each value of P, put it over Q. 1 over 1 is 1, 2 over 1 is 2, 3 over 1 is 3, and so forth. So basically, this is going to equal to all the values from P. That always occurs when you have just a 1 here. Now let's think about this. Ignoring the pi's, if I take r squared times half of r, that should give me about 72. 24 squared would be pretty big. 18 squared, 12 squared is 144. 9 squared is 81. No. 8 squared is 64. Probably not. 6 squared is 36. Okay, now that gets in the realm of possibilities. Probably not going to be this small. 2 squared is 4. 3 squared. I'm guessing somewhere in here. Now you could definitely use technology to graph it and see what it is, but I'm trying to do this by hand. Now negative doesn't make any sense for our radius, so I'll start with 4, and I'll plug that in synthetic division. This right here. So I'm going to have 1, negative 2. I'm missing the r, so that's 0. Negative 144. Add, multiply, add, multiply, add. Boy, that may be way off. May have been dreaming about 6. So it's 1, 6, add 4, 24, 24, 4, 2, nope. Let me double check. 6, 4, 24, 4, carry the 2, 12, 14, 0. Okay, so we got a 0. That means that though we're dealing with r, is our answer. Now, I could, since this is r to the third, this would be r squared, this would be r, and this would be no r, our constant term. And I'd have r squared plus 4r plus 24 equals 0. And if I went through and did this, it would give me an imaginary number, so that wouldn't go anywhere. So I got r is equal to 6. All right, let's come up here. R is equal to 6. Now this would be 1/2 times r. So I got 1/2 times 6 minus 1. 1/2 times 6 is 3 minus 1 would give me 2. That tells me my radius is 6 and my height is 2. And radius is equal to 6. Let's see if that makes sense. So pi times r squared, so 6 squared, times h, which is 2. 6 squared is 36, times 2 is 72, 72 pi. That makes perfect sense. So those would be our dimensions. The radius would be 6, and the height would be 2, whatever we're talking about, meters. And that was the instructions. Find dimensions of the right circular cylinder described.